we are going to talk about the Nerst equation. And the Nerst equation helps you deal with non-standard conditions for electrochemistry. I don't know when the last, I don't think we've done a problem this semester where the activity was equal to 1. So we want to deal with things that are not at standard state, so not E0. We need to find a way to get away from that. Where activities are 1, fugacities are 1, these types of things. So if we consider the equation, A plus some number of electrons goes to BB, we can say that E equals E0 minus RT over NF ln activity of B to the B over activity of A to the A. So we can simplify this equation saying that E equals E0 minus 0.05916 over N, the number of electrons that are transferred, times log A activity of B over, or to the B over activity of A to the A, and that's at 25 degrees C. So here's an example of this for just 1/2 reaction where you have solid phosphorus going to pH 3 gas. And there's an E0 for this that you can look up. So E equals the E0 minus 0.05916 over N, which is 3 in this case. 3 electrons are being transferred over, or times the log of the pressure of the phosphorus, the gas, over the concentration or activity of H plus cubed. And probably we can ignore activity just like we have been and just instead use concentration most of the time, unless you have a really salty solution. So you can also use the Nerst equation for a full reaction. So the first step is just to write the half reactions for both equations, where you have these are the reduction equations, like what you can look up in the book, where they're gaining electrons. So there you go. Then you write the Nerst equation for each, and you can solve it individually, where you have the concentration, where it depends on the concentration of silver and cadmium in solution. Find the answers to that. This is an example in your book, so you can look up the concentrations there. And then you find the net cell potential by using E equals E plus minus E minus, so cathode minus anode equals this math, and so you end up with 1.2 volts for the cell. And then you can write the net reaction. Alright, so the last thing that we're going to do is talk about how E0 and K, the equilibrium constant, are related. So E equals E0 minus 0.05916 over N log Q for non-equilibrium conditions. At equilibrium, E is going to equal 0, so E0 equals 0.05916 over N log K. And so those, you can just use that just like we've been using the delta G equals negative RT